I was expecting you. Come on in. This is my lab. This is my team in my lab. We sleep here. We doing the upright robot. Let me show you around. It's a cool room. This is when we put the stuff together. We had our pieces. We had our glue. We put the glue on those pieces. And we assembled something. It's in that corner. Now come on, it's the lab where we had to cut some wood, cut some plexiglass. You need safety, don't forget about these safeties first. Come on, you walk this. As you can see, we have an assortment of tools we're going to use, much of which I have no idea what they do. But what I do know is this saw. Come over here. Come on over here. Let me show you this saw. We use this saw to cut our plexiglass for our base. If it was on, it'd be spinning, but it's not on. So it's just going to stay right there, like that. It cut plexiglass, we cut wood. That was all we cut in here. Come on, let's go back in the other room. I introduced my family. This is Aubree. Say hi, Aubree. That's Temoor behind you. Hi. And Ike's behind the camera.
That's the other part of our shot.
Go back. Let me show you this corner. We spend most of our time at this table right here. We have our tools. We have many tools we were using. Let me show you. We got wires. We used these sticks to set up the base for the robot. We had epoxy glue. This is super glue. That keeps it sticky. That's not the one we use.
This is JB Weld, but it's actually epoxy.
We got more wires. Stay strapped, you know. That's the toolbox. So we assembled the robot over here, put those pieces together. Voila. You have a robot.
And there's our robot.
And our robot is right here. Why don't you come look at him? He's cute. We named him Wally Jr. After his father, we miss him. The whole 360, little Wally Jr. right here. Look at that. We got boards, a motherboard, no fatherboard. Sensors.
These are our two 9-volt batteries, one of which powers the Arduino Uno. The other of which powers the motor driver down here, which are connected to these two motors. We also have a sensor that's attached and taped very securely to the top piece of plexiglass right here, and that's what senses the tilt angle and allows for the feedback loop to happen. So when this senses the tilt angle, it sends a signal to tell the motors to adjust that tilt so that the degree of rotation is 0.
Alright, so right here is where I wrote the code. The code is basically what was uploaded to the Arduino, and it's what gives it the various power depending on the amount of tilt it has, or that is sensed by our MPU 6050 sensor. It's both a gyroscope and an accelerometer. The code pulls the data from the MPU 6050 and applies the proper amount of power to each of the wheels, each of the motors.
So we ran into a small issue. So we had compiled our Arduino code onto our Arduino and we had it working, and we were trying to tweak some of the values, and one of our motor ports went out. So it just stopped working. We tried testing the wires from the motor that wasn't working in the port for the one that was working, and it worked. So obviously it was the port that was the issue. So what we ended up doing was trying to route both of the wires for each of the motors into the same port. And this fixed our problem of the motors not working. However, now they work in reverse of each other, and our code was only ever adapted to work 2 different wheels simultaneously. So it's sending the same signal to one of the motor ports, and both of the wheels are receiving it, but they're reverse of each other. So essentially what that does is make our robot spin in a circle. When you flip it over, it still adjusts for the tilt. If you hold it straight, it doesn't spin, but if you hold it one way or the other, it does. So it's still trying to compensate, but the motors are going the same direction now, and when you put it down on the ground, it doesn't ever adjust because it just spins in a circle.
Okay. That angle right there is upright. Apparently our sensor's upside down.
So we flip it.